Students, last class I discussed about the important definitions: distance traveled, displacement, speed, velocity and acceleration. Distance traveled, the length of the actual path traveled by the body is called a distance traveled. Displacement, the change in position of a body in a particular direction is called a displacement. And speed, the time rate of covering a distance by an object is called a speed. Velocity, the rate of change of displacement is called velocity. And finally acceleration, the rate of change of velocity is called acceleration. So students, today class, equations of linear motion or kinematic equations. Now, a body traveling from one place to the other place. A body or vehicle, it moves from one place to another place. Example here, the point A is the one place A. The other point B. A body or object, it moves from one place to the other place. Example here A to B. The body at A, initial position, initial velocity U. U is the initial velocity. Beginning velocity. So initial position, time t equals 0 second. The body moving at A, initial velocity, time t equal to 0 second. After, the body moving along straight line. So up to B, here final velocity V, time taken 30 second. So here U is the initial velocity at a time t equal to 0 second. In beginning, initial velocity, time t equal to 0 second. So after you reaching one point, the final velocity v and time t second. Time t second may be 10 minutes or 1 hour or half an hour. So 1 minute equal to 60 seconds. So now the body traveling from A to B at a distance S. S is a distance between A to B. So now here U is the initial velocity, V is the final velocity. Change in velocity. Change in velocity by time taken is called acceleration. So now acceleration symbol small a. Small a equal to change in velocity. Change in velocity means final velocity minus initial velocity. The final velocity symbol what? V minus initial velocity U. So V minus U, this represents change in velocity. V is the final velocity, U is the initial velocity by time t. Now your acceleration A equal to change in velocity by time taken. Acceleration symbol represented small a. Do not mention any other symbol on capital A. Only should mention or written as small a. Change in velocity V minus U. V is a final velocity, U is a initial velocity by time. So acceleration A equal to V minus U by t. So now here A t multiply A into t, A t equals V minus U. A t equal to V minus U. So minus U comes to left side. So A t plus U equal to V. The minus U will take left side, so that minus here plus AT plus U equal to V. Finally, V equal to U plus AT. V equal to U plus AT. This is the first equation of linear motion. V equal to U plus AT. This is the first equation. V equal to U plus AT. So how you get this formula? V equal to U plus AT. First you know the definition of acceleration. Acceleration means the rate of change of velocity is called acceleration. Acceleration equal to change in velocity by time taken. Acceleration symbol small a, not capital A. So you should not mention, do not mention any other symbols. So A equal to V minus U by t. V minus U is the change in velocity, t is the time. So now multiply A into t, A t equals V minus U. you take left side. So AT plus U equal to B. So B equal to U plus AT. This is the first equation of motion, linear motion. In this equation, now you will calculate acceleration. So how to calculate acceleration? Now using this formula, A equal to V minus U by T. And also this equation, we will calculate time. So time T equals V minus U by A. So some numerical problems, how to calculate acceleration and time. So A equal to V minus U by T. And time, so A and T replace, T equals V minus U by A. This is the first equation of linear motion. V equal to U plus AT. After, how to calculate the displacement and distance? Already know the definitions. Distance travelled, the length of the actual path travelled by the body is called a distance travelled. And displacement, the body change its position in a particular direction is called displacement. So how to calculate displacement or distance? One more equation, second equation, S equal to ut plus half at square. Second equation of linear motion, S is the displacement and distance travelled, ut plus half at square, S is the distance travelled A to B. So the body moved from A to B. How to calculate the distance? Using this formula, S equal to ut plus half at square. U is a initial velocity. T is a time the body reaches. After the body reaches certain position, time T. So ut plus half A. A is the acceleration. How to calculate the acceleration? A equal to V minus U by T. And time. The body moved from A to B. The time taken for the body moved from A to B. So T is the time in second. So second equation of motion, S equal to ut plus half at square. And third kinematic equation are equations of linear motion. So V equals V square equal to U square plus 2AS. Third equation of linear motion. So V square equal to U square plus 2AS. So now here V is a final velocity, U is a initial velocity, and A is a acceleration, S is the displacement. So in this equation also you calculate acceleration. So acceleration is V square equal to U square plus 2AS. So this equation written as V square minus U square equals 2AS. Now A equal to V square minus U square by 2x. Here also you calculate acceleration. One more formula here. A equal to V square. V square is the final velocity. V is the final velocity. U is the initial velocity. S is the distance traveled from body A to B. So A equal to V square minus U square by 2s. Now the first equation, V equal to U plus AT, S equal to ut plus half at square, V square equal to U square plus 2s. The three are very important. Your numerical problems, how to solve with the help of the linear motion equations. V equal to U plus AT, S equal to ut plus half at square, V square equal to U square plus 2s. Students, the fourth equation of linear motion, Sn equal to U plus A into n minus half 1 by 2. This is the fourth equation of motion. Sn equal to U plus A n minus 1 by 2. This is the fourth equation of motion. The body traveling from long distance A to B. So U is a initial velocity, beginning velocity. A is a acceleration. The body to reach one final position take number of seconds, that is n second, in n second of motion. So the fourth equation of linear motion, Sn equal to U plus A n minus half. So Sn Sn equal to what? U is a initial velocity plus A is a acceleration, n is a body traveling long distance in n second. So n minus 1 by 2. So fourth equation of linear motion, Sn equal to u plus A into n minus 1 by 2. This is the fourth equation. And last fifth equation. A body traveling from here A to B, a distance S1, time t second. Then B to C, distance S2, time t second. So here also A to B, distance S1 in time t second. B to C, a distance S2 in time t second. So maybe first 5 minutes, how much distance covered body? After 5 minutes, also same distance covered by the body. How to calculate acceleration? Using formula A equal to S2 minus S1 by t square. Acceleration A equal to S2 minus S1 by t square. This is the fifth equation of linear motion. So now 5. A equal to S2 minus S1 by t square. So here 5 linear motion equations of linear motion. 5 equations are there. Or one more name, kinematic equations. Equations of linear motion are kinematic equations. The first equation of motion, V equal to U plus AT. Second equation of motion, S equal to UD plus half AT square. And third one, V square equal to U square plus 2AX. And fourth equation, Sn equal to, Sn is the nth distance. Sn equal to U plus A, n minus 1 by 2. N is the nth second of motion, nth seconds. Fifth one, A equal to S2 minus S1 by t square. These are important 5 equations of linear motions are kinematic equations. Friends, you know the important definitions. Speed, the time rate of covering a distance by an object is called a speed. Average speed, the total distance traveled by total time taken is called a average speed. And velocity, the rate of change of displacement is called velocity. So ds by dt. Some textbooks will be written as dx by dt. Some textbooks mention dx by dt. So anyone, ds by dt or dx by dt is nothing but the rate of change of displacement is called velocity. So v equal to ds by dt or v equal to dx by dt. So acceleration, the rate of change of velocity is called acceleration. So a equal to dv by dt. So here dv by dt is a mathematical differential calculus, differential formula. So dv by dt, the rate of change of velocity. ds by dt, the rate of change of displacement. So v equal to ds by dt. V is a velocity, ds by dt is a rate of change of displacement. And acceleration A equal to dv by dt. A is the acceleration, dv by dt is the rate of change of velocity. For example, a vehicle, how much change for velocity per 1 second. So this is A equal to dv by dt. So after equations of linear motion or kinematic equations is very important in your first lesson, motion in a straight line chapter. So the 5 equations is very important. So how we improve the knowledge of motion in straight line? The basic formulas or equations of linear motion: v equal to u plus ad, s equal to ud plus half ad square, v square equal to u square plus 2as, sn equal to u plus a, n minus 1 by 2, For last equation, fifth equation, a equal to s2 minus s1 by t square. In this lesson, a numerical problems how to solve the with the help of the equations of linear motion.